Hey, welcome to the first in a series of presentations on probability. I hope you enjoy them. What is probability anyway? That's a big question right here in the middle. What is probability? Let's go around the screen and see if we can find out. Okay, we've got a spinner up here. This little thing in the middle spins around and lands on a colour. The pointer lands on a colour. Find the probability of spinning yellow. What's your chances? I think that means you've got 3 chances out of a total of 8 different sectors it could land on. Not counting it might land right on the line, mightn't it, between the two? Might have to think about that. What about over here? I'm going to scrub out what's down there. I want you to see if you can work out what that is. Well, we've got a little bit of a number line here from 0 to 1. And it says down here to live forever is impossible. We're going to give that 0 chance. It is impossible at the moment, but medicine's come along pretty well, isn't it? And then up the other end, the sun will rise again tomorrow, and that's a certainty. So you're getting 1 out of 1, if you like. Getting the idea? What about this in the middle? An even chance. Head or a tail on a coin. I don't think they should have 2 coins there, just one. But you've got to know that one's a head and one's a tail, the 2 sides, I guess. And what's the answer? Right in the middle. What is the probability of landing a what? Landing on a head or a tail? Does it matter? We might think about that. I think they're both equal, aren't they? Equal chance. Unless there's something funny going on with the coin. Come down here and we've got a pair of dice. And just remember, if you just take one of them, it's called a die. D-I-E. And what's your chances of getting a 6 like that? That's the top number on a die. It goes from 1 to 6, 6 faces. Well, what about getting 2 6s? That could be hard to work out. And right over the other side here, come over here and have a look at this. That's a wheel, and this little ball is thrown in and it spins around and lands on a number. It's called a roulette wheel. And you might be able to try to work out what's the chances of that ball landing on, what's that, a red 25 it looks like. I don't know how many sectors there are on that wheel. You'd have to know that, wouldn't you? And what about this? Probabilities of 2 dice totals. Roll 2 dice and add them up. And why does 7 more likely? It's got a higher probability. Up here, they've gone to percentages now. I wonder where that comes from. Got a higher probability than any other total. That's interesting. Well, you can see we've got a bit of work to do to get our heads around this, but I think if you start developing your way of thinking right now, it'll be pretty easy for you. So come on down and let's have a look at a little problem. There's some screen clippings here from Hayes and Harris Publications, Year 7 textbook for Australian National Curriculum, so you should have a look at that. Here's a question. Anna and her 3 sisters each want to sit in the front of the car, on the front seat of the car. Their mother places each of their names in a hat and selects a name at random because we don't want the 4 girls to fight about who's going to sit there. Now, are each of the sisters equally likely to be selected? Is our first question. And well, it depends a bit, doesn't it? She's put all the 4 names in there. What are some of the factors which could affect their chances? Oh, there's that chance word again. Something to do with probability, I think. Well, I suppose the names would all be on the same size piece of paper. You might have to think about that. And also, I hope she doesn't peek in the hat. And also, maybe fold the piece of paper over so she can't actually see which name she's pulling out. All those things come in the word random. Random means each one has an equal possibility, equal likelihood or chance of being selected. Okay, equal chance. So there's some practical things you'd have to be sure of there to make sure they all had an equal chance. And yeah, then they would. We would give that a tick under those conditions. How likely is it that Anna will be selected? Well, how many pieces of paper are in the hat? Let's try and work this out. There are 4. And only one of them's got her name on it, so it's 1 out of 4. It's a fraction. Have you done much work on percentages? We could change that to a percentage, couldn't we? A quarter, 1 out of 4, a quarter of 100%, remember, means percentage. So a quarter of 100 is 25%. Okay, so you've got a quarter chance or 25%. We often use percentages in probability. How likely is it that she won't be selected? Well, that's one of the chances. That's a chance of one of the other 3 girls being selected. So that must be 3/4. I'm getting the idea. If it's not her, it's got to be one of the others. Okay, away we go. Let's start our journey. So come on down now. So here it is, chance. That's probability, I suppose, in a nutshell. Probability is to do with the likelihood or chance of events occurring. So this stuff in green, when you see it on the screen, is probably worth making notes of. Your probability notes. I don't know, you're going to put them in a separate book or in the back of your workbook? I don't know, but it's good to keep these things handy by. I don't know, it's to do with the chance. I think it's calculation of the chance, isn't it? I'm not sure. We'll have to think about that. Okay, so there's the first little bit of our language, our mathematical language to describe probability. Okay, let's go on down now. Here are some exercises for you, and I'm going to let you go on now and have a go with these. And if you toggle forward in the video, you'll see the answers later on. And I guess you should discuss those with your teacher and with each other. So pause the presentation now and have a go at these 3. And just remember, every question or 2 you should toggle forward so that you can check whether you're getting them right. Okay, away we go now. Here's some more from that set. Oh, look out for these red ones. The red ones here mean a bit more challenging. You're going to have to think about those. Okay, so pause it, have a go, and let's go and have a look at the answers here. Okay, there we are. All right, so check your answers, and let's go on with our next little bit of the journey. Here we are, some more language we use. The outcome of an experiment is a result we obtain in one trial of the experiment. Oh, hang on, experiment, that's science, isn't it? Well, it's also maths. We refer to when we're rolling a die or tossing a coin or doing any other sort of game like that. We call that an experiment. We're experimenting with how many times something might come up. And we call them trials of an experiment. So this is a bit of our language in working out probability, particularly where we're playing games and things like that. And an outcome. Gee, isn't mathematical language lovely? It's not ambiguous, no confusion with what it means. Outcome. What is coming out of the experiment? Okay. What is the result, if you like? And an event is something we're looking for. It's an outcome with a particular property. Well, particular property, yeah. Particularly if we are saying what's the chances of something, like rolling a 6, here it is down here, it didn't come up 6 this time, it came up 5. But your event that you're looking for is that. It's any outcome. But we have to have a particular one to calculate its probability, if you like. Here we go. If an event cannot occur, we did that number line, it's down on 0. If an event is certain to occur, we assign it with a probability of 1, or 1 out of 1. So probabilities are fractions. I think we got that from before. Probabilities are fractions, and we can convert those to percentage if you like. Okay, so you might write these green bits in your notebook. So pause it and have a go, and let's go on. All right, here we are, a little test for you. Assign the probabilities 0, 0.5 or 1 to best describe the chance of a newborn baby being a boy. Okay, what's our answer? Well, we reckon, looking at it from the experimental point of view of what's actually happened in our lives, we've got approximately the same number of men as women. And if you look at the theoretical side of things, biologically, what makes the difference between a woman or a man in terms of genes is a 50-50 chance, or 0.5. So you can look at it from the number of people within our world of men and women, or you can do it theoretically. Okay, so experimental and theoretical calculations. We'll come up against those in a minute. The chance of a man being 4 meters tall. No one has ever reached, no human has ever reached that height. So we would say the chance is 0. Okay, from our understanding of the world, that will be an experimental probability. Okay, I don't think we could work that out theoretically because there are too many factors that affect height. We're not sure exactly whether that would ever be possible. Here we are, the chance that the sun emits light tomorrow. Well, we certainly hope so. The chance of light in our experience is certain from the sun tomorrow, so the chance of light from the sun is 1, or the probability of getting light from the sun tomorrow is 1. Okay, you get the idea. I hope you're developing a way of thinking about this, making it clearer for you. Let's go on now. So let's have a look at these exercises. So again, do the same thing. Pause the presentation, have a go at the first couple, toggle forward, look at the answers and mark your work. Don't look at the answers first though, that'd be a bit naughty. Okay, let's go on. And there's the answers. Okay. All right, I hope you're getting a few right. I hope you're getting some idea. Ask your teacher, talk to your classmates if you're not sure. Okay, let's go on now. Okay, here's some more language. A sample space is a set of possible outcomes of an experiment. Sample space, why would we say that? Okay, it's a space or a set of samples. Oh, what does that mean? That is where we can take our outcomes from, if you like. It's all the possible outcomes. It's called the sample space. Now, when we do an experiment, our outcome will be from sampled from that space. We take a sample out of there. Okay, so a set of possible outcomes of an experiment, all the possible outcomes. Okay, is a sample space. Okay, so that's the idea. Let's have a look here. What's a sample space when you toss one coin? Well, not 2 coins here, but the sample space would be a head or a tail. A head, comma, tail. So the sample space would equal the set, curly bracket, head, tail. And when you roll a die, here we are, what's a set of possible outcomes? A sample space is a set of numbers 1 through to 6, like that. Okay, and here the spinner. Can you write down the sample space for that one? How many different sectors are there here? 1 through 8. So be the numbers from 1 to 8. Try to write that down as sample space equals set of right through to 8. Okay, get the idea. We're just building up some language. Don't forget, put that little definition in your notes now, in that green part there. Okay, let's keep going. Okay, here's some more to practice using the language and working some stuff out. Okay, pause the presentation, have a go. And there's some answers for you. Okay, check it now. Let's move on. It's getting good, isn't it? Do you feel you're getting more confident, getting an idea of the language we're going to use as well as the calculation? Okay, let's go. Okay, what we're going to do now is make a formal definition of the sorts of things that we've been doing. And here's our formal definition. The probability of an event, we write it like that. Sometimes we write PR, and then a bracket, an event. Because P in mathematics land later on stands for something else called permutations. So we don't want to confuse that. You can see it means probability here, but some books, I rather like this, put P with a little r before that bracket. So it's quite clear you're talking about probability. Okay, and what have we been doing? We've been counting up our chances, a number of outcomes, which we'd be happy with. I'll go back to the first screen. We had a spinner, and we said how many yellow sectors were there. There were 3. So that was our event, was getting a yellow, and there were 3 out of a total of 8 sectors, I think. So you get the idea. That's what we've been doing. So this is just a formal statement of what we've been doing. So again, put that in your notes, because we're building up a whole language, aren't we? Which when we talk mathematics and we talk in these terms, people will fully understand what we're doing. Okay, let's have a look at this little question down here. Tickets numbered 1 to 9 are placed in a hat, and 1 is drawn at random. Random. We can't have any bias. It's got to have each possibility, each member of that sample space has to have an equal chance of being drawn. Find the probability that number drawn is. Okay, so before we look at that, what are some of the restrictions on this experiment? So talk to your friends and teacher about that. What are some of the restrictions? The tickets numbered 1 to 9 are placed in a hat. Okay, what do you reckon? Tickets have to be what? Same size? Maybe should be folded over so you can't cheat and read the number. Should be maybe shaken up, perhaps. Can't look when you draw. All of these things will be necessary if the ticket is drawn at random, because a random, remember, means every item has an equal chance of being selected. Okay, that's a very important definition, a very important word, this. Equal chance there of being selected. All right, so the number drawn is 3 or 7. You will be happy with a 3 or 7. They're your favourite numbers, mate. So there are 9 possible outcomes. So the size of the sample space is 9. And you'll settle for either of 2. So you've got chance of 2 out of 9, PR. Probability of a 3 or a 7. See how we write it? See how we write the explanation of what we're doing here? It's a little mathematical language. It's good, isn't it? Very concise. What we can read that now and understand what's going on. There are 4 here. Let's look at the next one. A number greater than 5. Okay. Well, how many numbers greater than 5 are there? That's the first thing, isn't it? Come up to the definition up here. The number of outcomes corresponding to the event. Okay. There are 4 of them. So your chances are 4 out of 9. That's your probability. Okay, are you getting the hang of it? And what I think you probably got this from before, but we've got a language and we've got a notation, the way we write things now. Got to learn that as well. So don't forget, come up the top here. Don't forget to put that definition in your notes now. Okay, let's go down. Here's another example. 2 blue and 3 white discs are placed in a bag and 1 disc is randomly selected from it. So there it is there. Now, randomly means it's got to be in a bag. It can't be in this bowl that you can see through, because you might like to pick a blue one and subconsciously you're biased. Well, there's another word, biased. When it's not random, there's a bias. So you can't see inside the bottle here. It looks like a bottle. It's supposed to be a bag. And then, because you can't see it, and maybe what would we have to say about the discs? Exactly the same size and fatness, wouldn't they? Because otherwise you might be have a chance to draw one rather than the other. So to be equal in opportunity, random, you can't see them, they have to be the same size. Okay, what's the probability of selecting a blue disc? Well, how many are there? That's the first thing. Well, there were 2 blue discs. Okay, so 2 discs are blue, and there were 5 in total. So there's a 2 in 5 chance, or the probability of the outcomes you want, the event, over the total number of probabilities in the sample space. And your probability of a blue would be 2 out of 5. Okay, what's the probability of a white? Okay, well, the rest were white. So you could go back and work it all out again. 3 whites out of 5. Or what else could you have done? 2/5. All the rest must be white. So that must be 1 take 2/5. It's called the complementary event. It must be what's left from the total. It could be 3/5. So there's a shortcut way of doing it. Might think about that. You can count them up again if you wish, but if it's all that's left, this isn't a bad trick to do here. Okay, think about that one. Talk to your teacher and other students about that. That's going to come up later on. Okay, let's go on. So here's our last set of exercises, 15D, and I want you to do it again. Pause presentation, have a bit of fun with these. They're good, but I want you to practice your setting out, okay? You're setting out in our method now. You're setting out of the problem. It has to be neat and clear in mathematical probability language so everyone can understand it. Okay, let's go on. There's more questions to come here. Fairly long one, this one. Okay, pause it, have a go. Don't forget to toggle ahead. Check your answers as you go. Okay, we've cut it off down the bottom here. Sorry about that. Okay, you might have to talk to your teacher about that one. Let's go on and have a look at the answers. There they are. Remember, anything in red here is a more challenging question. So really get into those, enjoy those, talk about them. All right, how did you go? I hope you got a few answers correct there. All right, are you ready to go on now? And here's your final bit of this presentation. Here are all the words we've been using. And I want you just to go through and make sure you understand what each of them means. Okay, and I think probably discussion is the best here. I think we've done all this. Theoretical probability. Okay, that might be something different. But these are all something that, all these items, these words, are the key things that we've been talking about. So I'll just pause here for a minute and ask you to think about theoretical probability. And do you remember the other word I used? If it's not theoretical probability, what is it? How are there two of those? I only mentioned this a little bit. Okay, so have a discussion there. All right, let's have a look at this. Theoretical probability is looking at the whole thing in theory, the theory of the experiment, okay, that you're doing. So what's the theory when you're tossing a coin? You're not going to toss the coin, okay? You're just going to sit and think about it, the theory of it. There's two sides, and if the coin isn't unbalanced, if it's an unbiased coin, it's got equal chance of landing head or tail. So therefore, the theoretical answer to that is a half for a head. Chances or probability of getting a head is a half, and it's a half for a tail. Now, what's the other way of doing it? Well, the other way I did mention is experimental probability. Experimental probability. Okay, so what that means is you're actually going to do the experiment. You're going to actually toss the coin and see how many times heads or tails come up. Now, there's a bit of a question you have to answer now. Would they always be the same? Or how many times would you have to toss the coin to make sure they were coming up evenly? A half, 50% heads, 50% tails. Now, that's something for a later presentation in this series. So it really built up, and it's good. I want you to develop your what? Way of thinking. That's very, very important in probability, or important in problem solving and maths in general. Okay, so I hope you've enjoyed this presentation, and I look forward to seeing you in later ones, because there'll be a few of them. So cheers for now.